All right. Hello, hello. Is my sound working? That's the first thing to check. We've learned this lesson from day one. Um, hello. I think I've started a little bit early, so hello YouTube mostly. Oh no, there's people watching. Hello. Okay. It's day 3, and we're still going, just about. There's still people turning up to the stream, so I'm still here. Okay, I was having a look because we started a bit early. I was having a look at Simon was talking to me in the chat yesterday about his solution using a switch thing, uh, a switch expression rather than a switch statement. Um, so I was having a nose at what he did. He's also using records, which I'm not. I think what I've learned from this is that I need to catch up with my C# 8 and 9 features. Come on, computer, you've got this. There we go. So let's share my screen with everybody. Hello. If you've missed the first few streams, they're here. The GitHub's here, and link to 24. No, Advent of Code is down here too. Nearly said 24 days. Anyway, so here we can see data. This is Simon's solution to day 2. So what he's doing, he's got some records set up for the instructions and the positions. And is he using the instruction? Oh yeah, there's a definition of the instruction. Cool, definition of the position. So then he's creating his list of instructions with his parseLine function. Ooh, the regex, interesting. Then looping through each of the instructions. What he's doing is so he's creating a new position for each one. So that actually updates, creates a new record and sticks it in the position variable. And then he's doing this switch expression. So this is a sort of switch on type scenario. And then each one of these strings creates a new position, and the with command sort of creates a copy of the existing position and modifies it with any variables sorry, any of these that you specify. That's quite cool. I'm enjoying that. But it does highlight that I definitely need to catch up on these C# 8 and 9 features because I'm not confident enough to use them. Definitely not in a live scenario. Hello, people watching. Oh, thanks for confirming my sound's working, Seb, as well. Right, Advent of Code, day 3. So, the submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, contains a list of binary numbers which, when decoded properly, can tell you useful things about the conditions of the submarine. The first parameter to check is the power consumption. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, considering only the first bit of each number, there are 5 bits and 7, so 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. Considering only the first bit of each number, there are 5 0 bits and 7 1 bits. 1, 2, 3, 4, 5. 1, so this is the first bit. Most common rate is 1. The most common second bit of the numbers in the diagnostic report is 0. So the second bit of the gamma rate is 0. The most common value of the third, fourth, and fifth bits are 1, 1, and 0, respectively. So the final 3 bits of the gamma rate are 1, 1, 0. So the gamma rate is the binary number 10110 or 22 in decimal. The epsilon rate is calculated in a similar way. Okay, so as if that wasn't complicated enough, rather than use the most common bit, the least common bit from the position is used. So the epsilon rate is 01001 or 9 in decimal. Multiplying the gamma rate by the epsilon rate produces the power consumption. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is the power consumption of the submarine? Be sure to represent your answer in decimal, not in binary. Okay. I'm a little bit stumped as to where to start with this one. But let's do the simple bit of create a class. Create a new file at least. day3.cs. .cs. Let's create a namespace of day3. And a class called day3 as well until I work out what it's gonna be. And then we've got a property on here for the gamma rate, the epsilon rate. If anyone has any pointers here, by the way, please do stick them in the chat. And then we've got the which is So I can't think of a nice way in C# to store a binary number and interact with it as a binary number, because none of the sort of bitwise operators are going to be useful here, I don't think. Good morning, never too old as well. Thank you for saying good morning. That's nice and friendly. I'm definitely not using this as a distraction from what I've committed to. I might actually split them into an array of bits. Sure. I haven't got time to work out. Spent too long on this. Whoops. So I'm gonna get my input. We're gonna grab that as a string. Read that as a string from day3. Oh no, from the name that I just passed in as a parameter. I remember. Then what I'm going to do is this is going to be an IEnumerable of I don't like this. IEnumerable of bit. Can I use bits? I have to use booleans. Sure, let's use boolean. So I'm going to take my input. I'm going to for each one. What is it? I'm going to call this an input. So then my input variable can just be that. So I'm selecting, so a string is a char array, an array of char. So I'm checking that each char then, I'm converting that to Boolean by saying if it's equal to 1, the character 1, it's true. Kind of works. And then that's not how you type, Joe. I'm awake this morning, honest. Public void run. So let's have a look at the puzzle input. Ooh, longer. Okay. So let's take if bool, should it be true? Should what be true, Ravi? Hi, Ravi, by the way. Yes, it's not a Boolean at this point. At this point, I'm reading in the bits here. So this is going to be 1 or 0, and I'm converting it to a Boolean with that. Is that what you mean? Shout if I'm doing something wrong. I'm not working today, so this is the first time I've actually had to think so far today. And it's not going well. Oh, this might be longer than a half hour on this one. My brain. Right, so for each, I'm saying the word for each, so I'm going to write the word for each. I'm going to want a for. The length is going to be then the first input, this length. Count. Because we're now looping through these, each column here. I could have probably used a hash table or something, couldn't I? I'm committing to this for now, and then yeah, cool. Yeah, so it comes as binary, but I'm kind of ignoring the fact it's binary at the moment, because I can't think of a nice way to convert them to decimal, and then not happening. I need to convert to decimal at some point, but we'll leave that until later. I can manually do that bit if necessary at the end after I've run the calculation. So I'm looping through each column, and then I'm going to loop through each item in the collection. I'm not. I'm going to use I'm going to use some link here because link is simple. Element at, no, input, select, count. I'm going to count the number of rows that have count the number of rows that have that as true. So that is, I didn't want async in there. Where'd that come from? I think that's the number of bits, the number of ones. And then zeros is the number of rows minus the number of ones. And then if so we're building up a new number here, aren't we? Oh, I've got a way to do it. Var. Oh wait, which one are we calculating here? This is the gamma rate. So the gamma rate we're gonna add to it. Now I'm converting to binary. So if we've got more ones, if ones is greater than if zeros is greater than ones, that's easy. We just output a zero. We add a zero. Otherwise, what are my fingers doing this morning? They're not typing the keys I want them to. Otherwise, I'm going to add math power. Is that how it works? Power. 2 to the power of I plus 1. Maybe. And that's an integer. Sure, why not? I think that's right. So on the first iteration of this, it's going to be 0. And 2 to the power of 0. No, I think that's I. Okay, 2 to the power of 0 is 1. Yeah, that probably works. Cool. So the the epsilon rate is calculated in a similar way. Rather than using the most common bit, the least common bit from each position is used. Okay, so the like that. How do you write a number in binary? I really can't type today. There's not going to be an easy way, is there? Huh, awesome. So at each point here, I think I probably want to output the gamma rate. And the epsilon rate. Then in program CS, let's comment out day 2. I'm going to do a day 3 dot day 3 day 3 equals new day 3 with the name day 3 example. You need to copy that file actually, and then I'm going to do a day 3 dot run, and I'm then going to go console write line. Console write line day 3 dot power consumption. So let's get my inputs ready. Sure, let's run it. It's going to be very noisy. I'll do it. It's really hard developing on a 1080p screen, especially when you're trying to squash it. Okay, so I got 2, 3, 4, so that's not right. So let's run through this then. So I've already done my console write lines because I kind of predicted this wouldn't work. So since the most common bit is 1, the first bit of the gamma rate is 1. Second bit of the gamma rate is 0. So the second bit is 1, 2, 3, 4, 5, 6, 7. So my second bit is most commonly 0. So it's not added anything. And it's added, oh, I've done it backwards. So instead of that, I want the number of cons minus I. Because we're working backwards, we're doing the first number. First number first. Am I making sense? Yes, Harry, I definitely should. All right, all right, we'll do it. Oh, no, that's JavaScript. Is that right? Someone tell me if that's right. How string interpolation works in .NET? Yes. Okay, so now we're working backwards. So we're starting with the first bit and ending up at the end bit, but there should definitely be some ones in there. Number of columns is too high an index. This is getting messy. I don't know why I didn't just stick with an array at the end, because I've got to convert it at some point. The answer's correct, is it? 198. Oh yeah. But the gamma rate should definitely have a 1 in the first bit, not the last bit. Yep. Yeah. Yes, that is working. Okay, cool. So it's because we're working left to right as if we're reading it rather than in the correct binary order. Anyway, we're there. I think I overcomplicated it by switching to numbers at that point, but hey. Okay, so let's try that with the real input and see if that works. Thanks, Seb. I've been staring at that for ages. I was still looking at it backwards, despite having just flipped it. So let's try that with the real input. Bigger numbers. Good. We like bigger numbers. Yay! You get that point, Seb. That was that was all you're doing. I'd have been debugging for days. Right, 23 minutes past. Let's see if we can get this finished in the half hour. Okay, next you should verify the life support rating. Absolutely no idea what's going on. I barely get it. I'm just writing code that fits the description. I'll try and explain what I'm doing a bit better this time if it's not easy to follow. Right, so next you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Okay, both the oxygen generator rating and the CO2 scrubber rating are values that can be found on your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the first type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you are searching. Otherwise, repeat the process, considering the next bit to the right. Are you following this? I'll take that as a no. Hi, Buzzer. The bit criteria depends on which type of rating value you want to find. To find the oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find CO2 scrubber rating, determine the least common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 0 in that position being considered. Doesn't get any easier. Okay, for example, to determine the oxygen generator rating value using the same example diagnostic report from above. You start with all 12 numbers and consider only the first bit of each number. There are more 1 bits than 0 bits, so keep only the 7 numbers with a 1 in the first position. Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bits, so keep only the 4 numbers with a 0 in the second position. Okay, so let's start with the oxygen one. Let's start with the oxygen one. So it's going to be very similar to day 3. We could possibly do it to part 1, sorry. We could possibly do it in the same position, but for simplicity, I'm going to copy it. R2. So this bit's the same. This bit's the same. Oh, no, not in that screen. This screen, but on that side. There we go. Don't care about the gamma rate or the epsilon rate or the power consumption, so let's ditch them for now. What we are going to do though I'm going to create so I'm two arraying to make a copy of this initial array, which I don't think I need to do actually. Nah, ditch that. Because I'm going to reassign to it later. So that's cool. Just going to do this for oxygen for now. In fact, I'm probably going to ditch the number of rows is going to have to be in here. What am I using that for? Oh yeah. Okay, so keep only numbers in this numbers selected by the bit criteria for this type of rating value. Oh, no, we're reading this bit. Nope. Part 2. Bit criteria, most common value, only keep numbers with so I still need the most common one. Yeah, okay, cool. So the number of rows is going to change for each for loop. Okay, so that's still fine. So the most common bit is so if there are more ones than zeros, then it's a 1. Yes, because I'm converting back to Boolean now. So then I want my input to be the input where the the current iteration, so the current column is most common, right? Morning, Simon. We were just talking about you earlier. We're looking at your Visual Studio solution, and I decided that I need to brush up on my C# 8 and 9 features. I'm definitely not confident enough to use records and switch expressions and things like that in a live demo at speed. Oh no, I've missed my half-hour window. So keep only the numbers. I've got only the numbers with that. If you only have one number left, stop. This is the rating value for which you're searching. Okay, so at that point, I'm going to do it again, right? So I've reduced my input to only the ones with that most common bit, that 1 or 0. But I actually need to, if I've only got one number left, so I don't know what happens. I just assume the data. I assume it's fine. If rows is 1, break. Yeah, rows is length. If Rose is 1, then I'm going to set. I need to convert it back to let's not convert it yet. Let's just stick it up there. What's it called? This O2 generator rating equals rows dot first. Oh no. Took longer because you mistyped a less than as a greater than. Yep, that's not amazing. I've been using link, haven't I? Why doesn't it like first? Oh, and nah, that's why. Input. There we go. Okay, so I think that's gonna work. Does it walk me through? It does walk me through the oxygen generator. Okay, so let's see what that does. I assume the example is the same. The keyboard's just disconnected. Go to something, generating. Yeah, Simon, I was admiring your setup earlier. Oh yeah, I need to make that nullable, don't I? I think, or just set it to default value. Not in day 1, not in day 2. Let's close those. Let's just set it to that for now. System Boolean array. Hooray! Just what we wanted, I think. So O2 generating, let's at least spit it out as binary. Can you toString on a byte array? Char array, even. Evidently not. Oh, it doesn't like it. Why doesn't it like it? assignment. That's cool. So much slower debugging, isn't it? Okay, so IEnumerable input. It's 11 of them. And then there are 6 of them. There should at least be 7. Sorry, there are 7. 0 indexing and all that. Okay. We've got 7. And we, oops. Get out of there. Stop going. The input is now 5. Yeah, that's not right. It's never actually getting to one row because I'm not filtering them out properly. So the number of ones, first iteration again. Why is F10 so aggressively going into things? I don't care. Take me out. Yeah, step over, please. Why won't you step over? 7. Yes. Zeros are 5. So it's 7 and 5. Cool. That's what we want. And we knew that's what we wanted. Let's just skip to that. Number of zeros is number of ones, sorry, is 5. There should only be 7 rows at this point. 5 rows. If I got this the wrong way around, so ones is 5 and zeros is 0, then this should be 1, so that should be a true. It is a true. I at this point should be 1, yeah. So my rows, there's 5 of them for some reason. Let's look at my input. True, so it's kept the ones with the ones. True, 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 false. Now I was looking at the second number. And there should be 1, 2, 3 ones. Because we're looking at sort of 1, 1, 1, 2, 3. Ah! Why is input not? This is still looking at input with a capital I. I don't think this is it, but just to. Why can't I do it first? I'm not. No, that's fine. That's the same error we had before. Let's try that again. Seven, 5, 3, 4. Okay, so it is something funky happening with the IEnumerable. Wait, where's the 4 come from? Number of rows shouldn't be 7. What? One. So it's got the 3 correct this time. I've done something horrible with reference types. I don't like it. Also, because the way I've decided to store these as IEnumerables of Boolean, it makes it very difficult to work out, to diagnose. It takes it a real pain to look at what's going on. So I'm very tempted to swap this out for a string. Yeah, just so I can work out what's going on. Just diagnostic wise, it feels a bit nicer. Well, yeah, that simplifies that as well. Anywhere I'm doing an element at, I can now just replace it with that, and I just say equals 1. It's a bit messier once you're down here, but 1, otherwise 0. Wait, x is now going to be already a string. Already a string. Okay, that simplifies most things actually. Yeah, absolutely. Code intent is less obvious, but it's easier to work with. It's so much easier to debug. Have I fixed everything? Let's find out. number of ones is 7. So that means that we can probably look at this input. Oh, look at that. We can see what's going on. So we can look at the ones and the zeros. Most common answer is going to be 1. And then we're looking for all the input, reducing the inputs to only where we've got 1. So now we've only got the ones that start with 1. The number of ones, rows is still 7. It went down that time. Rows should always have been 7. Let's start again. So rows is 12, ones is 7. Yes, that's what we want. Zeros is 5. Okay, then rows is 7. Number of ones is zeros is, that's right. This is working. It never gets here. Do I have to loop? Where's the breakdown? Starts with 12 numbers. Then considering the second bit, oh yeah, I forgot to compare it to this as we were going through. What am I doing? F5. I don't need that window open. I mean, I do actually in a minute. But... So 7 1 bits, 0 5 bits. We've established that one. 7 5. And we've got 3 and 4. Third position, 3 and 1. Yeah. Fourth position, 2 and 1. The fifth position, they're an equal number of bits. I forgot this one. So actually, we want a greater than or equal to here, and I think that will fix it. Because we want to prefer ones. I forgot that clause. Seven 3 4 3 3 2 2 1. Oh, I'm looking at rows. Still didn't get there. I was looking at the wrong variables, which doesn't help. Might take. Can I stick that in a new window? No, I don't want to. No. Right, so we've got 7 and 5, 7 5. I'm going to point with my hand, but you can't see what I'm doing. Then we've got 3 and 4, 3 and 4. Then we've got 3 and a 1. Yep. Then we've got a 2 and a 1. In the fifth position, there's an equal number of 0 and 1 bit. Zeros and ones is 1. So we want the most common actually to be 1, which it is. And then there should only be one number left. Oh, we've come out of the loop at that point. So it's kind of if there's one number before that point or down here, So actually, I can just break out of that loop and set the generate. Yeah. Okay. That makes sense. Am I making sense to anyone else? I suggest you reread the question again carefully. Ooh, is that one of the ones I've just caught? I hope so. I think it was that one. Yes, good. Thank you. You're giving me tips, but I'm I'm reading them about 5 minutes after you posted them. Today I even moved the chat so it's right there. So in theory I should be able to see it more easily, whereas I had it hidden away before. Are we going? No. I'm feeling confident. Just gonna run it. 10111. 10111. Okay, so I still need to convert that to decimal, but we'll come on to that because I also need to do the CO2 scrubber. So starting again with 12 numbers and consider only the first bit of each number. Okay, so let's look at the least common value. 1 and 0 are equally common. Keep the values with a 0 in the position being considered. Okay, so I really should not duplicate this code because it's pretty much the same logic, but I'm a grown man and I'm going to do what I want. So this one is actually an equals because it's the least common one. And I want to take the least common I didn't mean to make that equals at all. So the less common one is ones are less than zeros. And if there's an equal number, I want to take the 0. So that is less than, not less than or equal to. I want to do that. And then I want to do, instead of O2, CO2 scrub rating. Let's just see if that works straight away. Yes, it does. Okay, so let's have a quick search for so I only know how to convert from this binary notation. I don't know how. Is it just a convert? Yeah, it is. Oh no, that's the question. Oh, cool. No, we know it's binary, so that's fine. Read the question, Joe. Read the question. So down here, we're actually going to do a. Why did I put a bracket in there? That's not an integer. That's fine. Will be soon. And then to work out the answer, we multiply them together. run it with the test once more. No. Oh yeah. I was doing this. $23, $10, $230. Yes. So this has been a complicated one. I haven't appreciated this morning. Let's try it on the inputs. Whew. Done. I feel like that was quite a slow one. I want my stats. Where's my stats? Leaderboard, personal stats. There we go. Oh, pretty similar. Let's not look at the rank. It's because I wait for you guys to come and join me, so that's why it's so low. Nice one. Okay, that's done. Again, yeah, I'd really would have liked to have done something that handled binary numbers a bit better, but really it's got not much to do with binary except the conversion at the end. So I guess using a string makes sense in that case. I'm definitely going to be looking at what Simon's written again today, out of interest. Let's commit and push those changes up to GitHub. If anyone wants to have a poke through and improve my code, feel free. Do pull request as well if you make some changes to make it a bit neater. I'd be up for seeing what anybody does to it. Thanks very much for joining me. Not that different. Hooray! I like that. Yeah, I'll have a nosy later. So that was actually a very long one. Did that give me a time estimate of 6 minutes? It was lying. I've been here an hour. So that way, other videos and GitHub and all that sort of thing at the link on the screen. And I'll be back tomorrow. See you later.